In this exercise, we'll continue our study of servos, motors, and drivers. We'll continue from where we started last week, which was where we used a servo. We took it apart, we looked at the motor, and we saw how it converted high RPM with low power through gear reduction, converting speed for torque to create an output drive that was a lot stronger than the motor itself. We also use this little device to allow us to test our servo, and I will hook that back up again just to demonstrate that. And we'll need some DC power, so I'll hook up a battery, watching the polarity, making sure that black is ground, red is the center, that's the positive voltage. And then from there we're able to affect and turn our servo. Let's see if we can zoom in a little bit. There we go, and I'll try it again. So we can see the gears in there turning and see it converting again the high speed from the motor. And what we also noticed in our servo was that there was a potentiometer in there just below the surface that's able to read what position that it was at, and that's what makes a servo work well in knowing its position, is by using the signal from that back. But that's not what we're studying today. What we want to do is replace this box, this controller box, with an Arduino Pro Mini, and that's what we're going to work on next. I've zoomed back out so you can see our LCD platform. We call it that because it's a platform with an LCD display. This LCD uses the I2C to be able to read from address pins 4 and 5 the digital output that we might want it to display. And it has its power pins. We're also using this extension here that allows us, it's from YW Robot, allows us to convert 12 volts DC into 5 volts through this regulator and supply plus 5 and ground to our two rails on either side. I will plug that in and let it power up, and we're using the LCD platform software, and it looks like our software is ready to go. So let's look up our servo. So take from your kit, find a servo, and I'm going to use this Velcro and plug it in on this side. I have two wires connected to the plus and 5 that's provided here, and if you remember your colors for class convention, we have brown and red. On a servo, red tends to always be in the center, and so we'll count on that. So plus and ground are hooked up, and then we want to hook up the signal line. So for that, we'll use an orange wire. This orange jumper wire will simply go from pin 9 that has been pre-programmed in our software to the signal line of our servo. The other thing we're introducing today is this potentiometer. I'm going to unplug it for a moment so you can see how it's connected. Potentiometer is nothing more than a resistor that goes around this outside and comes back out here. So we hook our plus volts to this side, or VCC, our ground to this side, and as we turn the knob will touch literally one side or the other, or along this path, and generate or create an output of the voltage that it happens to be. The variable resistor will let us pick a voltage between our plus VCC and ground and output it on this center pin. When I plug that in, it's important to line them up and make sure that they match the wires that I have here. Here is ground, plus 5, and I've put a yellow wire on the middle wire, or the middle lead. So I'll plug that in. There we are. I also think it would be useful to know what that voltage is. So we have, along with the other equipment, our digital display voltage meter. I'll plug that into the rail. Notice I have red and blue for the plus and ground, or VCC and ground, and it's lit up. That makes this now a voltage probe. Wherever I plug this in, I can read the DC voltage. And right now it's about, happens to be 2.3. So if I turn it all the way clockwise, I'll find out what my plus voltage is, plus or minus a little. Looks like 4.6. And if I turn it all the way down to the lowest voltage, I should see very close to 0 or 0. So just leave it in the center. Now this input is going to go to A0. Now I've already added, let me pull that for a moment, I've already added a resistor to A0 and A1. I didn't want those input pins while we were developing our platform, our test circuits. I didn't want those to float around. So I've tied them to ground. And you'll notice when I plug this in, whatever was seen as ground is now seen at this new voltage. And our servo corresponds to that. So let's see what the range is for our servo. If I turn this all the way down, voltage is 0. Again, we're looking at the voltmeter here. And then clockwise, I'll turn it all the way up to the highest voltage possible here, which is 4.8. And I want you to notice our servo is also turning. And our code, if you look at our display output, our code is showing that it goes from what looks like the lowest is 3, at least for this configuration, all the way up to 180. Well, it turns out that a servo controls the pulse width modulation that comes through this pin 6 out to our servo. It has a range of 0 to 180. And if you think about it, if we look at this, if this is 180 and this is 90, these numbers could directly correspond to the angle that this turns at. So that means that in our software we can configure, or we can equate whatever angle we turn this at to be the angle that's going to be represented here. That can be useful. But that's not all we're going to study today. I also want to look at DC voltage or DC motors. So this DC motor I have here is a common one. We'll plug it in to the side and we'll just snap it on so it doesn't move. And I will add this motor controller card. This card has several wires to control it. I've decided for the input pin, I don't know if you can see that, but it says IN. I believe it says IN1? EN1, enable. I'm going to hook that to pin 13. I actually have a reason, and we'll talk about that in a moment, to want to be able to turn this motor drive off during its operation. We'll dress our cables a little bit. We'll bend them to stay out of the way. There. And then I have these other two pins, which correspond to INs 1 and 2. And for this controller, this takes 2 lines in. And I will tell you now, that's for the ability to go forward and backward. Now on this, when we connect this to our Pro Mini, we want to look at the pin numbers of the Pro Mini. We want this to hook up to pin 6 and pin 8. And it looks like I've missed, so 5 and 8, there we are, because that's what our software is programmed to talk to. And I'll dress it so it's out of the way. And I'll turn my knob, and only my servo turns. Well, that could be a problem. Let's take a look and see what our display says. I'll zoom back out. Our display says that, yes, that's all that's happening. Oh, A0 has the values, what would be used for our motor control. Well, let's see if I can move this wire from A1 to from A0 to A1. There we are. So now as I turn this, still nothing happens. But I can see pin 13 blinking. Well, I know my code's working because as it passes 0, it turns off and on. Not anymore, but it did. You have to take my word for it. Okay, so, but the motor didn't turn. So it turns out that this controller, if I don't hook up the plus and ground, I'll hook up just the ground. There we go. So as I hook, so with just the ground connected, this circuit's now connected so it has a reference to these input voltages. But I didn't hook the plus up. I don't want our Pro Mini or our circuit to be driving our motor. I want our motor to have its own input voltage. I'm going to tilt our LCD platform enough just so you can see that there is a terminal for ground and V in. That allows us to put or hook up outside battery voltage, which these two wires will provide. Now underneath this I have a battery pack. This battery pack has 4 AA batteries, and those AA batteries provide around 6 volts DC, and we can probably test that. So I'll take a moment and hook those up. Okay, I've connected the two lines and give them a little tug to make sure that they're securely in there. Make sure you get the polarity right, otherwise this chip will burn up. And the next thing to do is we'll try our potentiometer. Oh, still nothing's moving. Well, let's put it back to 0. I bet it's because on the other side we have an off-on switch for our battery pack. Now we'll turn it on, and now we'll see what it does. So as I turn it, the value is changing for one side, and I can hear and see that my motor is turning. That's moving right along. Change it back down, and it goes through 0, and then the other value increases. And well, I've noticed though, on this side, no matter what I change it to, it seems to run at the same speed. Once I get down to 128, which is exactly halfway between 255 and 0, it turns off. Where this side, it starts out slow, very slow, at about 1. I can hear it turning at 98, 90. Apparently, if it goes too slow, it just isn't enough to turn. But at 255, it's variable. So there's something different about what's going on. Well, let's take a look at our connections and see what we have. See if there's something that's needs to be changed. Well, I have it on pin 6 and 8 to drive our inputs, and there's only one direction that's failing. It's as if one of these two is not putting out the range of voltages to change the speed for a motor. Well, in doing some checking and checking the code, it looks like pin 8 is not a PMW or pulse width modulation value. I'm going to change it to pin 5 because pin 5 is, and I'll hook up our computer and I'll export this changed software. Okay, the program's been loaded, it's restarted itself. That's the version number, and let's move this. Well, first let's try it. Nothing happens here because we're not talking to pin 8 anymore. So let's move this wire from pin 8 to pin 5. And now it's going slower. So in reverse, we have speed control, and forward we don't. Okay, here's what I'd like you to do. On your program, on your code, within your code, there are some comments. And in those comment lines, I want you to find, here, we'll take a look. We'll switch over and we'll take a look. I want you to take some measurements.